Welcome to Unit 3. In this unit, we are going to be learning how to graph linear equations. So in Unit 2, we learned about how to solve linear equations. Now in this unit, we're going to learn about the graphs of those linear equations. However, before graphing them, we must discuss what we will be using to graph these linear equations on. And what we're going to graph them on is known as the xy plane or the Cartesian coordinate system. So below, for our first example, we're going to draw out what this xy plane looks like, and then we're going to plot all these points below on that xy plane. So let's see here. I'm going to first by drawing a vertical. That's an oval. I want a line. Thank you. I'm going to first start off by drawing a vertical line like this, and then I'm going to draw a horizontal line like this. Now, this horizontal line here, this horizontal line is known as the x-axis. And then this vertical line here is known as the y-axis. And on this x-axis and the y-axis, we have a number line. So right here in the center, this is 0 on both the x and y-axis. Now, here on the x-axis, we're going to have 1, 2, 3, 4, and 5. And then over here in this direction, we're going to have negative values. -1, -2, -3, -4, and -5. Now on the y-axis, we're going to do the same. So above the x-axis is going to be all of our positive values. So we're going to have 1, 2, 3, 4, and 5. And below our y-axis, we're going to have all of our negative values. -1, -2, -3, -4, and -5. I apologize for not leaving a good amount of room for this. Alrighty. So we've drawn out the x-y axis. These are our tick marks. So we have over here is our negative tick marks on the x-axis. These are positive tick marks on the x-axis. These are positive tick marks, or the positive direction in the y-axis, and this is our negative direction in the y-axis. All right. So a couple things before we start plotting points. This point here in the center, it has a special name. It's known as the origin. O-R-I-G-I-N. Origin. So this point here is the origin of the xy plane. And that's all you need to know about the xy axis. So let's get started by plotting some points. So points are always given x as x comma y. A fixed point x comma y. So what this means is the value here for point A is going to be 1. So our x value for point A is going to be at 1. So that's going to be our x value for point A is here at 1. But then we also need to go up 2 in the y direction. So we're going to go right 1 in the x direction, and we're going to go up 2 in the y direction. So this here is going to be our point A. So point A is going to be here. This is point A. Now point B, let's see. We have 0 as our x value, so it's going to be here. And then our y value is 3, so we're going to go up 3. 1, 2, 3. So that's going to be point B. Point B is going to be here. Point C is -3, 4. I encourage you to pause the video and see if you can give point C a try. And assuming you have worked through it, let's go through it together. So point C is -3 in the x direction. So we're gonna go to the left 3. 1, 2, 3. But the y direction, it's +4. So we're gonna go up by 4. 1, 2, 3, 4. So point C will be right about here. So 4, gonna go to -3, right about here. Now point D is -2, 0. So we're gonna go -2 in the x direction, but we're not gonna move up and down at all. So it's gonna be 1, 2, y is 0, so point D is here. I encourage you to pause the video for point E and see if you can plot that point. And assuming you have plotted point E, let's go through it together. So our x value is -5, so we're gonna go left to -5. 1, 2, 3, 4, 5. And our y value is also -5, so we're gonna go down 5 units in the y direction. So it's gonna be 1, 2, 3, 4, 5, right about here. So point E is going to be right here. This is point E. Then we have point F, which is 3, -4. So that means our x directions is going to be positive by 3 units. So 1, 2, 3. And we're going to go right 3 units. And then we have a y value of -4. So we're going to go down by 4 units. So we're going to go 1, 2, 3, 4, right about here. So this is point F. And last but not least, we have point G. I encourage you to pause the video and give the last point a try. And assuming you have plotted point G, let's work through it together. So our x is 0, so that means we're going to stay here, but our y value is also 0. So we're not moving anywhere. The point 0, 0 is right here. And it just so happens that actually 0, 0 is the point of the origin. So 0, 0 is the origin. That is the origin. That's the definition of what the origin is. So point G is the definition of what the origin is on the xy plane. Alrighty. So now that we understand what the xy plane is and how to plot points, let's dive into graphing some equations. However, prior to doing so, let's take a moment to review the following vocabulary. So we have something called the y-intercept. And the y-intercept is a vocab word to describe a point where the graph intersects the y-axis. So what that means is, let's say we had a line that looked like this on this graph, right? The y-intercept would be right here, the point where the line crosses through the y-axis. And then we have the x-intercept, which is where a point in the graph that intercepts the x-axis. So using that same imaginary line that I'm drawing here, the x-intercept would be here, where it crosses, the point where it crosses through the x-axis. And then with linear equations, we also have something called slope. And the slope is the change in y over the change of x. So in other words, most people have heard this before, the term that slope is rise over run. So what that means is, let's say this imaginary line that I was drawing out before, like this. Slope measures how fast this line is going up and how fast it's going to the left or to the right at the same time. So that's what slope measures. And then our last important vocab for this section of notes is the slope-intercept form of an equation. So given that m is the slope and that b is the y-intercept right here, this is the slope-intercept form. Y equals mx plus b. So using all this information we've just gone over, let's put it into some practice. So in the following examples, we are going to graph positive linear equations. To do so, let's determine the slope. So we need to determine the slope and the y-intercept of the following linear equations. Then, once we got that, then we're going to graph them on the xy plane using the slope that we found and our y-intercept. So, example number 1, we have y equals 1/2 x plus 3. So, looking up here, we have this equation, y equals mx plus b, and we're told that m is the slope. So m is the value that's being multiplied by x. So in this case, our slope is going to be 1/2, because 1/2 is being multiplied by x. So here, we're going to write, change it back to black. Slope, our slope equals 1/2. That's our slope. And then our y-intercept, that's our b value, or in other words, what's being added to x. So what's being added to x? That's 3. So our y-intercept is 3. Now using this information, let's graph this line. So I'm going to draw out the y-axis and the x-axis. I'm going to say this is our x-axis, this is our y-axis. Now we're going to draw out some tick marks. 1, 2, 3, 4. -1, -2, -3, -4. We're going to go up 1, 2, 3. Yeah. We're going to go up a little bit more. Well, I guess we can't. So I'm going to put 4 there. And then I'm going to bring this line down a little bit more. Go -1, -2, -3, and -4. Okay. Now that we got that drawn out, let's identify. The first thing I'm going to plot is our y-intercept. So the y-intercept is 3, but what does that mean? And where would that point be? Well, as previously defined, we know that the y-intercept is at the point where the graph intersects the y-axis. So if the y-intercept is 3, that must mean the y value has to be 3 right here. So that is our y-intercept. Specifically, the y-intercept is at the point 0, 3. Because our x value here is 0. Our x, we're not going anywhere left or right, so our x value is 0. And then our y value, we're going up by 3. So that's our y-intercept. And our slope is 1/2, which that means we're going to rise up by 1 value. We're going to rise up 1. And then 2 means we're going to run by 2. So what does that mean? Rise means we're going to go up or down. Rise is our change in y values. So using this value, this y-intercept here, we can use that and use our slope. So we're going to go up by 1, we're going to rise 1, and then we're going to run by 2. So we're going to go 2 in the x direction. So we're going to go up 1 and 2 in the x direction. So one point is going to be here, right here. But notice, we can't go up any further using our tick marks that we've drawn out. So, where'd my point go? Let me redraw that, because maybe it went away. There you go. So there's my point. Now notice we don't have any more tick marks. That goes beyond 4. So we can't go up anymore. But what we can do is go the opposite direction. So we can go down by 1 and left by 2. And I'll explain here why this works. So if we go down, that means we're going down a negative value, right? So we're going down by -1. But if we go left in the x, if we go left, that means we're going negative in the x direction. So we're going down by 1, -1, and we're going, our run is going to be -2. But what's a negative divided by negative? Negative by negative, that's positive, right? So even though, yeah, we're going down and we're going left, those are two negative values. But remember, slope is a quotient. Slope means we're dividing two things. It's the change in two things divided by another. So if you have two negative values, it still ends up being positive because a negative divided by negative is a positive. So that's why you can do this as well. All right. So I'm going to plot one more point. Using this point, we're going to go down 1 and left by 2. And here you go. That'd be our last point that we're going to plot. I mean, you can plot infinitely many points if you really wanted to, but that's just not that logical, unless if you have a lot of time. Oh, why did that happen? Okay, let's try this. Let's see if this looks. Yay! Let me do a different color. Alrighty. So that is our linear equation. What is happening? This is our linear equation. So that's what it looks like. Y equals 1/2 plus 3. That's your linear equation. Alrighty. So taking a look at example 2, I encourage you to pause the video and do all the same steps we just did in example number 1. And assuming you have given it a go, assuming you've identified the slope and the y-intercept and plotted it from there, let's go through it together. Okay, so we have y equals 1 plus 2/3 x. So I'm going to do it in green this time. Slope, our slope, using our definition, y equals mx plus b, where whatever is being multiplied by x is our slope. That must mean 2/3 is our slope. So 2/3 is our slope. And then we also have our y-intercept that we have to define. So our y-intercept is whatever's being added to our slope. So we're adding a +1 here. So our y-intercept is going to be at 1. So specifically at the point 0, 1. Now this is written a little bit differently, because in this first problem we had 1/2 x plus 3, but this time our expression 1/2 x, or x expression, is moved over to the right. But it doesn't matter. We can write the y-intercept first if we want, and then our slope, or we can write our slope and then our y-intercept. However, usually, most of the time, we write our slope first, then our y-intercept. But we can write it in any order that we want. All right, so now that we identified that, let's plot our xy plane and plot our linear equation here. So I'm going to go... Okay, so here is our x-axis. This is our y-axis. And then 1, 2, 3, 4, -1, -2, -3, -4. Then we have 1, 2, 3, 4, -1, -2, -3, -4. Okay. So we know our y-intercept is at 0, 1. So we're starting here and we're going up by a value 1. So this is our y-intercept. Now our slope is 2/3. So that means we're going to go up by 2 from our y-intercept. So we're going to go 1, 2. And then we're going to go left or right by 3. Because we went up by 2, we're going to have to go right by 2. Because we go left by 2, that means that we're going to the negative direction. Since we went up, we're going into the positives, and a positive divided by negative is a negative. So if you did this, this would no longer be a positive slope. So you have to go to the right by 2. So we're going to go up by 2 and then right by 3. So we're going to go 1, 2, 1, 2, 3. So right here. Right about here. And then now that we have this plotted, if we were to go more towards this direction, we'd go off the tick marks in our graph. So let's go the opposite direction. Let's go down and left. So we have to go down by 2. So we're going to go from here, 1, 2, down by 2. Then we're going to go left by 3. 1, 2, 3, right here. And now that we have 3 points, we can now graph our linear equation. But this time, I'm going to use the pink again. I'm going to make this. Oh, it's not pink. Okay, well, this is our linear equation. This is our linear equation. Y equals 1 plus 2/3 x. Alrighty. So now that we've seen a couple examples of positive linear equations, now we're going to take a look at negative linear equations. So just by looking at these examples, whenever we can tell it's a negative linear equation automatically by just looking at the equation. So since there's a negative in front of this x, that's telling us that this slope is negative. We have a negative slope, we have a negative linear equation. Same thing for this other example, we have a negative slope. So that means we have a negative linear equation. Here, both our slopes are positive, so that's why we had positive linear equations. All right, let's get into it. So we're gonna do the same process as we did up there. We're going to determine the slope and y-intercept and then sketch the graph. So for example 3, we have y equals negative x. So our slope, we just have a negative x. Why do we think our slope is going to be? Well, pretend this negative is essentially being multiplied by this x. So think of this as a negative 1 times x. So our slope is negative 1. Now you might be asking, isn't slope a fraction? Isn't it rise over run? You are correct. In this case, when you have slope that's an integer, that's a whole number, an integer, you can just put it over 1. If you have a slope that's an integer, that means your x direction is over 1. So you're going to go down by negative 1, and you're going to go right by positive 1. That's what our slope is. And then your y-intercept, well, our y-intercept, we don't have a plus or minus b value here. So that tells us that our y-intercept is at the point is when y is 0. So our y-intercept is at the origin, 0, 0. So let's graph this, see what it looks like. So we're going to draw our y-axis and our x-axis. Okay. So we have our x-axis and our y-axis. So our slope is negative 1, or in other words, negative 1 over 1. And our y-intercept is at the point 0, 0. So this is our y-intercept. And I'm going to draw some dash marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So our slope is negative 1 over 1. So our rise is negative. So that means we're going to go down. So we're going to go down 1. But then we're going to go right by 1. So we're going to have a point here. And then we're going to go down again by 1. And then we're going to go right again by 1. And then we're going to go down again by 1, right again by 1. Down again by 1, right again by 1. Okay. And now let's go the other direction. We're going to go up by 1, left by 1. Up by 1, left by 1. Now, if you're confused as to why are we going up and right, and then why do when we go down, why are we going to the right? Now, if you're wondering that is because, right, when you go down, you're going down in the negative direction. And when you go right, you're going in the positive x direction. So a negative divided by a positive is a negative. And that's good. That's what we want because we have a negative slope. Now when we go up, we're going up in the positive direction. So a positive, left is negative, so positive divided by negative is also negative. That's good. That's what we want because we have a negative slope. Perfect. So we're going to go up by 1 again, which is here at the value of 3, up by 1, and then left by 1. And this is our slope. This is what our line looks like. There you go. It's very roughly sketched, but oops. But this is what it looks like. So just take a quick notice. Notice the difference between a positive and a negative slope graphically. Notice that the positive slopes go like this, but the negative slopes go like this. So they're completely different directions. Alrighty, so for example, I think this is no, we have a couple more examples after this. But for example, for pause the video and do everything we've done. Identify the slope, y-intercept, and graph the line. Assuming you have gone through it, let's go through it together. So our slope, in this case, is going to be negative 1/2 because negative 1/2 is being multiplied by x. And then our y-intercept is going to be negative 3 because that's our b value, what's being subtracted from our term with the x. Alrighty. So now, let's draw out the xy plane. Let's plot our y-intercept. This is our x-axis, y-axis. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So our y-intercept is at the point -3, so it's going to be at the point 0, comma, -3. So we're going to go down by 3. And our slope is negative. So we're going to go down by 1. And then we're going to go right by 2. So down by 1 and right by 2. Because we have a negative divided by a positive. Because a negative divided by a positive is a negative. So we're going to put the point here. Go up by 1. So we have a positive. And then we're going to go left by 2. Positive divided by negative is a negative. Perfect. Go up by 1. Positive. Left by 2. Negative. Positive divided by negative is a negative. Perfect. And there you go. This is our linear equation for this one. Alrighty. So now we're going to be given some graphs, and we're going to go the opposite way. So given the graph, we have to come up with the slope-intercept form. So for example, number 5, I am going to first have to identify the y-intercept, which is here. Y-intercept, that's at the point 0, 4. Now to identify the slope, well, I'm going to go from the y-intercept, and I'm going to go up 1, 2, and I'm going to go right by 1. So we're going to have a rise of 2, and we're going right by 1. So our slope equals 2 over 1, or in other words, 2. So using this information, our linear equation is going to be y equals mx, and our m is our slope, so it's going to be y equals 2x, and then our y-intercept is at 0, comma 4. So it's going to be y equals 2x plus 4. Now looking at our final example for this section, I encourage you to pause the video and work through it. And assuming you have gone through it, let's go through it together. So our y-intercept is going to be here at the point 0, comma 1. So y-intercept is at the point 0, comma 1. And then our slope, well, let's start from a y-intercept. And well, let's see if there's a point on this line where it fits perfectly into like a crevice of a box. So like here, something like here. So let's go down. So from y-intercept, nope, that doesn't quite perfectly intercept to the point. So we're gonna have to keep going down. Not quite, right here. This looks like this is intersecting right through this point, -2, or yeah, 5, comma -2, because they're x and y. So 5, comma -2. So let's go. Let's see how much it goes down by rise. So we're gonna go down 1, 2, 3. So we're gonna go down -3. So our slope equals -3 over rise over run. So we're gonna go from here, see how much we have to go right by. 1, 2, 3, 4, 5. So we're going right by 5, and that's the positive x direction. So our slope is -3/5. So using that information, our linear equation is going to be y equals -3/5 x, and the y-intercept is at the point 0, 1. So it's going to be y equals -3/5 x plus 1. And that's your final answer.